Hello, and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of factoring trinomials. This is standard A.10E in the great state of Texas, and we are using item number 44 of the 2018 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have a trinomial here, tri, prefix meaning 3, right? So we've got this 9r squared minus 4r plus 3 terms there, plus 1. And it is in this form ax squared plus bx plus c. When we have it in that form, we can grab each of these coefficients. That's what we're needing here. We want to grab the a, the b, and the c. So my a is going to be this leading coefficient. That's 9. All right, so we can say a equals 9. We've got this b right here. It is a negative 4, right? So that's going to be very important. The signs make a big difference here. That's my b, and then my c is just going to be 1, positive 1. All right, now there are many different ways to solve this. I prefer the diamond method. It is a highly effective and efficient algorithm. And so what we do in the top here is we are going to multiply the a and the c. So my a is 9, my c is 1, put the product, all right, just a positive 9 up at the top, that's fine. B goes down below, that's a negative 4. Okay? And then we are going to write ax, and then one of the factors goes as the denominator here, ax, and then one of the factors go over here, because we are going to try to factor here. So my a is 9, it's going to be 9x over 9x over, we're looking for those two denominators. Because what we're doing is we're looking for the factors of 9 that multiply to 9 and add to negative 4. Okay, so let's look at the factors of 9. And here's the thing. If we are going to add to a negative 4, that means at least one of the factors is going to have to be negative, right? But if we're going to multiply them to a positive 9, that means both the factors are going to have to be negative. So we're going to have to keep it like this, right? Because two negatives make a positive when you multiply. So negative 1 times negative 9, right, that is going to multiply to positive 9. But it would end up adding to negative 10. So we're going to kind of keep track of that because I'm looking for what multiplies to 9 and then adds to negative 10. Okay, so I've got negative 3 and negative 3. Well, that multiplies to positive 9, but that adds to negative 6. That's it. I mean, those are the only factors of 9. It's not like it's 36 or something that has a whole bunch of factors. Okay, so this is letting me know that this j right here is in play. Okay? Because if there are no real factors, I mean, because this is literally what it is. I need to be able to multiply it to positive 9 and add to negative 4. The fact that it's a negative 4, like I said, lets me know that at least one of the factors is going to have to be negative. If I want to multiply two factors and come up with a positive result right up here, they both have to be negative, right? Even if they weren't both negative, even if I wanted to make it positive, there's no way I'm going to add any combination of 1 and 9, 3 and 3, whether one's positive, one's negative, both positive, both negative. None of that ever makes 4, positive or negative. Okay? So these are looking at various factors, but you know what? They're not even giving me both factors. If I had both factors, right, what I could do is I could just FOIL them out to see if it ever pops up to right here. But this is tricky. It doesn't give me both factors. It only gives me one. So it's been forever trying to find it. It's not going to work. The answer is J.